Hello everyone, in this lecture I will solve different problems in vectors, and this is a supportive material for previous lecture. The link for the lecture will be in the comments. In different occasions, the notation A and theta will be shortened that A equal to A cosine theta I hat plus A sine theta j hat. Now let's start with question number 1. If A equal to 15 and 80 and B equal to 12 I minus 16, what is the magnitude of A minus B? Now as we can see here, A is in polar coordinates, so this is R and this is theta. Now, since this is in polar and B in Cartesian coordinates, we have to convert A into Cartesian coordinates. So AX here equal to R cosine theta and AY equal to R sine theta. R in this case equal to 15 and theta equal to 80. So in this case here, AX equal to 2.6 and AY equal to 14.77. So A as a vector equal to 2.6 I plus 14.77 j hat. Now the magnitude of the vector A minus B, let's find A minus B first. A minus B equal to minus 9.4 I hat minus 30.77. So the j hat. So the magnitude A minus B equal to square root of 9.4 square plus minus 30.77 this. So A minus B in magnitude equal to 32. In this question here, what vector A and B are shown. What is the magnitude of vector C if C equal to A minus B? This is vector A and vector B. Now to find A minus B, vector C equal to A minus B, now we need to analyze A into its x and y components, and we need to analyze B into x and y components. Before doing that, let's rotate the coordinates, assuming that this is x and y. This is x and y. If we rotate the coordinate in such a way, B will be matched with the x-axis, and this is y-axis. Now, in this case here, A equal to AX I hat plus AY j hat, and B equal to BX I hat and 0 j hat. Now, the simplest and easiest way to solve this is to create a simple table. So this is A, this is X component, and this is Y component. The X component for vector A is A cosine 60, and the Y component for A is Y sine 60, and the X component for vector B is just B, and the Y component is 0. You do the math for this one here. Now A equal to 40 and Y, so this is A sine 60. Now you do the math for this one here. Vector C equal to A minus B, which equal to minus 30, and this one here equal to 34.6. Now the magnitude for vector C, it's equal to square root of 30 square plus 34.6 square, which equal to 45.8. So this is the magnitude for vector C. If vector A equal to 12i minus 16j and vector B minus 24i plus 10j, what is the magnitude of vector C, which equal to 2a minus b? Now, C as a vector equal to 2a minus b. So in order to find the vector C here, we need to multiply vector A with 2 and subtract b from it. In this case, it's equal to, when you multiply vector A by 2, you will get 24i minus 32j plus 24i, this one from here, and don't forget this is minus, and another minus from here, it becomes minus minus, it's plus 24i minus 10j, and in this case vector C equal to 48i hat minus 42j hat. On other words, the magnitude for vector C equal to square root of 48 plus 42, it's actually minus square, or equal to 63.7, almost 64. So this is the magnitude for vector C, which equal to 2a minus b. Another case, if vector A equal to 12i hat minus 16j hat, vector B minus 24i hat plus 10j hat, what is the direction? Now, the same question as before, but in this case, we look for the direction of the vector C equal to 2a minus b. We just find vector C equal to 48i hat minus 42j hat. In other words, tan theta equal to y over x, or minus 42 over 48. In other words, minus 41.2 degrees. If vector C equal to 10 meters and 30 degrees and vector D equal to 25 meters and 30 degrees, what is the magnitude of the sum of these two vectors? Now, we look for vector E equal to vector C plus vector D. And remember, this is in polar coordinates, so we have to transfer these vectors into Cartesian coordinates. So Cx here equal to r cosine theta, or 8.66, cy equal to r sine theta equal to 5, and dx equal to r cosine theta equal to minus 16.1, dy equal to r sine theta, which equal to 19.15. Now, vector E equal to cx plus dx I hat plus cy plus dy j hat, or in other words, minus 7.44 I hat plus 24.15 j hat. E as a vector equal to square root of magnitude here equal to 7.44 square plus 24.15 square, which equal to 25.3 meters. Now, same question, but in this case we are trying to find the direction of the sum of these two vectors. Now, vector E, as we solved it before, equal to minus 7.44 I hat plus 24.15 j hat. So tan theta equal to minus 24.15 divided by 7.44 or equal to minus 3.25. In other words, theta equal to minus 72.9. Now, if we look to vector E, it's negative in the x-axis and positive in the y-axis. Let's just have a quick sketch here. It's negative in the x-axis and positive in the y-axis. So this is angle theta that we just find here. It's 72.9. In this case here, as we all know that theta is measured from positive x-axis counterclockwise, like this one here. In this case, theta, or phi, let's name it, equal to 180 minus 72.9. In other words, it's equal to 107 degrees. A vector B, when added to vector C, yields a resultant vector which is in the positive y direction and has a magnitude equal to that of C. Now, what is the magnitude of vector B? Now, vector B, when added to vector C, the resultant vector is vector A, and the magnitude for vector B and C has the magnitude of vector A, as it's mentioned in the question here, equal to the magnitude of vector C. Now, B plus C as a vector equal to A, Y, J hat. This is mentioned in the question. The resultant vector, which is in the positive y-axis direction. So it's positive y-axis direction here, and the magnitude equal to vector C. Now, in this case here, A equal to AY J hat, and the magnitude for vector A is the magnitude as vector C. Now, C equal to square root of, now vector C, 3i plus 4j, 9 plus 16, or in other words, equal to square root of 25 or 5. Now, AY, in this case here, equal to 5. Now, B plus C equal to 5j hat, and B in this case as a vector equal to 5j hat minus vector C. Just move this one into the other side. 3i minus 4j hat. Simply it's equal to minus 3i plus j hat. So the magnitude for vector B, it's equal to square root of minus 3 square plus 1 square. It's equal to square root of 10, or equal to 3.16. This is the magnitude of vector B. If vector B is added to vector A, the result is 6i plus j. If B as a vector is subtracted from A, the result is minus 4i plus 7j. What is the magnitude of vector A? Now, to solve this one here, let's find B plus A equal to 6i plus j hat. Now, A minus B here, it's equal to minus 4i plus 7j. Now, we look for the magnitude of A. You just add these two equations together, and in this case here, 2a equal to 2i plus 8j, In other words, A as a vector, it's equal to I plus 4j, and the magnitude for vector A, it's equal to square root of 1 square plus 4 square, or square root of 17, or 4.12. If C equal to 2.5 centimeter and 80, it's in polar coordinates, the magnitude and direction of C 2.5 centimeter and 80 degrees. Now D equal to 3.5 centimeter and 120 degree, and E in this case equal to D minus 2C. What is the direction of E? Now E equal to D minus 2C, in this case here. Now Cx equal to R cosine theta, or 0.43, Cy R sine theta, or 2.46, dx equal to R cosine theta minus 1.75, and dy equal to R sine theta equal to 3.03. You just create a simple table. This is x component, and this is y component, and 2c in this case equal to 0.86. You just multiply this one with 2, and the y component, you multiply this one with 2 as well, 4.92, and d, you just leave it as is. D here equal to minus 1.75 and 3.03. Now find D minus 2C. This is E equal to D minus 2C equal to D minus 2C equal to minus 2.6 I hat plus minus 1.89 j hat. Tan theta, it's named tan phi, equal to y over x, and phi in this case it's tan inverse 1.89 2.61, or phi in this case equal to 35.8 degrees. Now when we draw this one here, vector E, it's negative in x, negative in y, so it's like this, in this direction. So this is 35.8 degree. Now remember, theta is measured from positive x-axis counterclockwise, this case here. So theta actually equal to 180 degree plus 35.8, or in other words, it's equal to almost 216 degrees. If vector C is added to vector B, the result is minus 9i hat minus 8j hat. If B is subtracted from C, the result is 5i hat plus 4j hat. What is the direction of B to the nearest degree? Now in this case here, C plus B as a vector equal to minus 9i minus 8j. Now C minus B equal to 5i plus 4j. In this case here, you subtract these two vectors and you will get 2b equal to minus 14i minus 12j, or b equal to minus 7 I hat minus 6 j hat. Tan phi, in this case, it's equal to minus 6 minus 7, and in this case phi is tan inverse 6 over 7. Phi, in this case, it's 40.6 degrees. Now have a quick sketch here. You will see vector B, it's in the negative x-axis and negative y-axis. It's located somewhere here, and this is 40.6. Theta is measured from positive x-axis counterclockwise. In this case, theta equal to 180 plus 40.6, or in other words, theta equal to 221 degree almost. A vector A is added to vector B 6i hat minus 8j hat. The resultant vector is in the positive x direction and has a magnitude equal to vector A. What is the magnitude of vector A? Now, vector A is added to vector B 6i hat minus 8j hat, and this one equal to c I hat, or vector A in this case, it's equal to vector A, because the magnitude of the resultant vector equal to A minus 6, this magnitude, I hat plus 8j hat. Now the magnitude for vector A, it's equal to square root of A minus 6 square plus 8 square, or in other words, A magnitude equal to square root of A square plus 36 minus 12A plus 64. And remember, A here is the same as A here. Now you square both sides of this equation, you will get A square equal to A square plus 36 minus 12A plus 64. In other words, this A square cancel out. 12A equal to 100. In this case, A is the same as magnitude, by the way. Here it's equal to 100 divided by 12, or 8.3. Now, same question, but in this case we look for the direction of A. Back to the result we have in the previous example. A as a vector equal to 8.3 minus 6, this is I hat, plus 8j hat, or A as a vector equal to 2.3 I hat plus 8j hat. Tan theta equal to A divided by 2.3, or theta equal to tan inverse 8 divided by 2.3. Theta in this case equal to 74 degrees. And since A it's in the positive x-axis and positive y-axis, so this theta here is measured from positive x-axis counterclockwise. No need to add anything here. If two collinear vectors A and B are added, the resultant has a magnitude equal to 4. If B is subtracted from A, the resultant has a magnitude equal to 8. What is the magnitude of vector B? Now, two vectors are collinear. It means that they are parallel to each other, and in this case here, B equal to C A as a vector. Now, the magnitude of a plus b equal to 4 and the magnitude of a minus b equal to 8, and you substitute b with ca, and you will get a plus c, a equal to 4 and a minus ca equal to 8. Other words, magnitude of a 1 plus c equal to 4, magnitude of a 1 minus c equal to 8. You divide these two equations, you will get 1 minus c divided by 1 plus c equal to 2, or 1 minus c equal to 2 times 1 plus c. And this equation is actually valid except that c will never be equal to plus minus 1. Now we have different possible solutions for this case here. Now if c is greater than 1, in this case here, c minus 1 equal to 2 plus 2c, and in this case c equal to minus 3. Now based on the condition we have here, c equal to minus 3, and we just assume that c is greater than 1, so this is actually false statement or false condition. And if c in between minus 1 to 1, and in this case here 1 minus c equal to 2 plus 2c, or in other words c equal to minus 1/3, and based on the condition, yes, this condition is true, and if c is less than minus 1, in this case here 1 minus c equal to minus 2 minus 2c, in this case c equal to minus 3, and again this is a true condition. Now you substitute this one back in these two equations here. A times 1 plus minus 3 equal to 4, and in this case here a equal to 2, or a times 1 minus 1 over 3 equal to 8, in this case a equal to 6. Now if a equal 2, and we all know that b equal to ca, in this case b equal 6, and if a equals 6, then b in this case equal to ca, or b equal to 2. When vector A is added to vector B, which has a magnitude of 5, the vector representing their sum is perpendicular to A and has a magnitude that is twice that of A. What is the magnitude of vector A? Now let's just represent the question here. Now this is vector A. The resultant vector is perpendicular to A with magnitude 2A. So if this is A, this will be 2A, this one here. And the other vector B in this case here equal to 5. So A, remember, head to tail, so A plus B, tail to tail, head to head, this is the resultant vector which is perpendicular to vector A. Now in this case here, B equal to 5, and this is A and this is 2A. Now A square plus 2a equal to hypotenuse here b squared 25 and a squared plus 4a squared equal to 25 and 5a squared equal to 25. In other words, a equal to square root of 5 or 2.2. So this is the magnitude of vector A. Starting from one axis, a camel walks 25 kilometers in a direction of 30 degrees south of west and then walks 30 kilometers toward north to a second axis. What distance separates the two axes? Now let's just represent the situation here. The camel walks 25 kilometers in a direction 30 degrees south of west, assuming that this is north, this is east, and this is south, and this is west. Now 30 degrees south of west, it's like this one here. So this is 30 degrees. Then it's 25 kilometers. Then walks 30 kilometers toward north. So directly like toward north, this is 30 kilometers. This one here. So this is axis 1 and this is axis 2. Now the distance between the axes is actually the resultant vector in this case. So A in this case, again, draw simple table, component, and this is y component, minus 25 cosine 30 minus 25 sine 30. Remember, when you analyze this one here, it will be in the negative y-axis, and when you analyze this one here, it will be in the negative x-axis. Vector b, on the other hand, equal to 0, no x component for vector b, and actually it's equal to 30 in the y-axis. So you do the math, you will find the resultant vector minus 21.6 and 17.5, and let's name it d as the distance. So d as a vector equal to minus 21.6 I hat plus 17.5 j hat. The magnitude for vector d, which is the distance between the two axes, by the way, it's equal to square root of 21.6 minus sine square plus 17.5 square, and it's equal to 28 kilometers. Now same question, but in this case we are trying to find the direction from the first axis to the second axis. In this case, d, as we found it before, it's equal to minus 21.6 I hat plus 17.5 j hat. Tan theta, it's equal to minus 17.5 divided by 21.6. In this case, theta, it's equal to minus 39 degrees or 39 degrees west of north. Degrees in here. The three forces shown act on a particle. What's the magnitude of the resultant of these three forces? Now we need to find magnitude of the resultant three forces in this one here. Now, before working with these forces, we have to analyze them into x and y components. So let's just draw a table here. X component, y component. Now vector A has x and y components, or 65 cosine 30. Remember, the one with the angle takes the cosine, the one without the angle takes the sign. 65 sine 30. And again, remember the direction of the arrow in this case, it's positive x-axis and positive y-axis. B, this one here, is actually minus 30. This is B, and no y component for B. Now C, on the other hand, it's minus 20. This one here, sine 20. And this one here, minus 20 cosine 20. Now vector C, it has negative y component and negative x component. Now find this one here equal to 56.3, and this one here 32.5, and this one minus 6.84, and this one minus 18.8. Add x with x and y with y. Vector D is the resultant force equal to 19.46 I hat plus 13.7 j hat. Now the direction of this resultant force, now the magnitude for vector D here equal to square root of 19.46 square plus 13.7 square, or equal to 23.8. So this is the resultant force magnitude. Now same question, but in this case we try to find the direction of the resultant of these three forces. Now D from the previous example equal to 19.46 I hat plus 13.7 j hat. Now tan theta equal to 13.7 divided by 19.46, and theta, it's tan inverse 13.7 divided by 19.46, or theta equal to almost 35 degrees. Now if vector C is added to vector D, the result is the third vector that is perpendicular to D and has magnitude equal to 3D. What is the ratio of the magnitude of C to that of D? Now similar to the previous one, now vector D, this is vector D here, and the resultant vector is perpendicular to D, this is D, with magnitude equal to 3D. So this is the resultant vector, this is 3D. Now from the head of D, draw C to this one here, this is C. Now the C square, hypotenuse C square equal to D square plus 3D square, and in this case C square equal to then 10D square, or in other words C over D equal to square root of 10, or C over D, the ratio equal to 3.2. The displacement of the trip of 10 centimeter long minute hand of a clock between 12:15 and 12:45 p.m. We actually need to calculate the displacement of the trip. Now, if we draw a clock, and this is 12 here, and this is 6. Now, between 12:15, it's 10. This is 10, and this is 12:15, and 12:45. This one here, 12:45. There's another 10. Now the displacement in this case is the distance from starting point to end point. in this case it's 10 plus 10, so displacement equal to 20, and the angle in this case equal to this one here, it's 180 degree. A student decides to spend spring break by driving 50 miles due east. So if you just have quick sketch here, so he drives 50 miles due east, then 50 miles 30 degrees south of east, so I just turn a little bit, this is 30 degrees, another 50 miles, then another 50 miles 30 degrees south of that direction, so it's like something like this, and continue to drive 50 miles deviating by 30 degrees each time until he returns to the original position. So in this case here, this student is just driving and deviating from initial position like this. How far will he drive and how many vectors must he sum to calculate his displacement? Now the student will drive, in this case, as we can see here, it's a polygon, and the exterior angle for this polygon, it's equal to 30 degrees. The total angle of the polygon is 360 and deviation angle is 30 degrees. Now number of polygon sides, let's name it like this, number of is actually equal to the total number of the polygon itself, which is 360, divided by the exterior angle, which is in this case 30 degrees. So in this case it's equal to 12. 12 is the number of polygon sides. Now each side of this polygon has a length of 50 miles. In this case, total distance equal to 50 miles times 12, or equal to 600 miles. Now the displacement, since the students start from this position and end up with the same position, so the displacement in this case equal to 0. Given that a plus 2b equal to x1 I hat plus y1 j hat and 2a minus b equal to x2 I hat plus y2 j hat, what is a? Now a plus 2b equal to x1 I hat y1 j hat, and 2a minus b is actually equal to x2 I hat plus y2 j hat. You add these two equations together, you will find 5a equal to x1 plus x2 I hat plus y1 plus 2y2 j hat. Now a as a vector, it's equal to 1 over 5 of this one here, x1 x2 I hat plus y1 to y2 j hat, and this is actually vector a. Given that a plus b equal to x1 I hat plus y1 j hat, a minus b equal to x2 I hat plus y2 j hat, what is a? Again, a plus B in this case equal to x1 I plus y1 j, a minus b equal to x2 I y2 j. You add these two equations together, 2a equal to x1 plus x2 I plus y1 y2 j, or a equal to half x1 x2 I hat plus y1 y2 j hat. The vectors a and b and c are shown below. These are three vectors here. Which diagram below correctly represent a plus b plus c? Now let's see here. Vector a, just leave it as is. Now you shift vector b and you move the tail of b with the head of a. And remember, the length of vector b, it's equal to 1, 2, 3, so 3 units from this one here, so it's equal to 1, 2, 3, so vector b must end up somewhere here. And vector c, again, from the head of b, you draw the tail of c, and c in this case, it's equal to 2 units, and since this is 4, this is 1, 2, so vector c will end up somewhere in here. So this is vector c. The resultant one, or the resultant vector a plus b plus c is this one here. Now from this one, tail to tail, head to head, and from this one here, you compare it, it will never be this one, not even this or this. So this one you compare, it will be this one right here. The diagram below shows the path taken by a sailboat taking sideways because it cannot sail directly into the wind. As you can see here, this is north, this is east, and this is 1000 meters. So this is 2000, and the distance here is 1732 meters, and the total here is 6298 meters. The total distance it travels is, now we need to calculate the total distance. So if this is 2000 and the height of this one is 1000 and the distance is 1732, and this is again the same, it's 1732, so this distance, this one here, is 2000 as well. Now same rule here, this will be again 2000 meters and again 2000 meters. So the total distance in this case, it's 2000 plus 2000 plus 2000 plus 2000, or in this case the total distance equal to 8000 meters. Now same question here. The diagram below shows the path taken by sailboat taking sideways because it cannot sail directly into the wind. Now but this one here, the total displacement of the sailboat, the vector sum of its displacement OB, BC, CD, and DE. In this case, remember, the displacement is actually, we are interested in the beginning and in the end point. So in this case, this is the displacement, this one here, which equal to displacement equal to 6298 98, and directed this way here, let's say east. Vector A has components +5 and +7 along the x and y axis respectively, along a set of axes rotated 90 degrees counterclockwise relative to the original axis. The vector's components are, now we have here two vectors. Let's just have a quick sketch here. Vector A, it has +5 and +7. So it has +5 in the x-axis and +7 in the y-axis. It should be something like this. And the point here, it's 5, 7. Now, if this vector is rotated by 90 degree, so this is 90 degree, this one here. Now the resultant will be the intercept with the x-axis, it's -5, and the intercept with the x-axis is equal to 7. Original vector A equal to 5i plus 7j, and the new vector A after the rotation, it's equal to -5i plus 7j. Calculate the cross product between vector A and vector B. Now in this case here, vector A equal to 3i hat minus 3j hat plus 1 k hat, and B equal to 4i 9j 2k. In order to find A cross B, this one here, open a determinant like this, I, j, k, and in the second row, this one here, write the A components, which is in this case 3 minus 3, 1, and in the third row, write the B components, which is in this case 4, 9, 2. Now, A cross B equal, you hide this one here and this one here, you will find 2 times -3, it's -6, minus 9. I hat minus j hat, you hide this and this, 2 times 3, 6, minus 4, plus k hat, you hide this and this, 9 times 3, 27, minus 12, 27, minus 12, it's a plus k hat. You do this, you will find that it's -15 I hat minus 2 j hat plus 39 k hat. Calculate the dot product of A and B. Now vector A in this one here equal to I hat plus 2j hat plus 3k hat, and B as a vector equal to 4i minus 5j plus 6k. Now A dot B equal to, remember when you dot product two vectors, you only multiply I with I, j with j, k with k, and the result is a scalar quantity. So A dot B in this case, 1 times 4 is just 4, plus 2 times -5, it's -10, plus 3 times 6, it's 18. So A dot B equal to 12. Same as the previous example, but in this case we need to calculate the angle between these two vectors. Again, A as a vector equal to 1i hat, 2j hat, 3k hat. B as a vector equal to 4i minus 5j plus 6k. To find the angle between these two vectors, remember A dot B equal to magnitude of A, magnitude of B, cosine theta. And cosine theta in this case, it's equal to A dot B divided by magnitude of A, magnitude of B. We just calculated A dot B equal to 12, and magnitude of A, it's equal to square root of 1 square, 2 square, 3 square, or in other words, it's equal to 1 plus 4 plus 9 equal to square root of 14. B, the magnitude of B equal to 4 square plus 5 square plus 6 square, which equal to 16 plus 25 plus 36, or equal to square root of 77. So cosine theta, it's equal to 12 divided by square root of 14, square root of 77. In this case, cosine theta equal to 0.37, and theta equal to cosine inverse 0.37, or theta equal to 68.3 degrees. That's it. Thank you for watching.